So we have the equation y equals x squared minus 8, which I graphed the parabola. And we have the point P over here, which has coordinates x, y. Now P could be anywhere, but we're trying to figure out how to express the distance between some point P on the graph of this function and the point 0, negative 1. So we have this point 0, negative 1 right there. We're trying to come up with the equation for the distance between the 2 points. So it's helpful to remember what the distance formula is, and the distance formula comes from the Pythagorean theorem. So in a general shape of a function, if we take 2 points, one point has coordinates x1, y1, and the other point has coordinates x2, y2, we see that if we build a right triangle, then the vertical leg of the right triangle has a length of y2 minus y1, the difference in the y coordinates. The horizontal leg of this right triangle has a length of x2 minus x1, and so if we square that, so a squared plus b squared equals c squared, Pythagorean theorem, x2 minus x1 squared plus y2 minus y1 squared equals this distance squared, and if you take the square root of both sides, you get this distance formula right there. So that being said, now we want to express the distance between point P and this point over here that has coordinates 0, negative 1. So point P, the difference in the y coordinates, so the distance then would be the difference in the y coordinates, which would be y minus negative 1. Square that, and then plus the difference in the x coordinates, x minus 0 squared. Now there's a problem with this right now anyway. We can fix that in a moment. But the problem is that we've got a y in here and an x. We don't want the distance expressed using both x and y. That's too many variables. So let's go ahead and simplify this a little bit first. We have y plus 1 squared plus x squared. Okay, well, if you keep in mind, the key to understanding how to express the distance just using one variable is the relationship between x and y. Well, y, any point, the point P has a point that has x, y coordinates that are actually on this curve. So the x is always the x. The y, we can replace y with x squared minus 8, because if the point is on the curve, then the y coordinate will always have a length of, or have a value of x squared minus 8. So everywhere we see a y, we're going to just put we're going to put an x squared minus 8. So we're going to go ahead and fix this, and replacing y with x squared minus 8, we see we can simplify inside the parentheses x squared minus 7 squared, and I'm going to write it like this so it's easier for me to visualize when I multiply them out. And then I am going to multiply them out, use the FOIL method. X to this x squared times x squared is x to the 4th. Then we have minus 7x squared, another minus 7x squared, that's a minus 14x squared, plus 49 plus x squared. Simplifying by combining like terms, we have x to the 4th minus 13x squared plus 49.